This question, we're going to show that a radical expression is equal to just a radical value. Okay, so we can probably jump through each of these a bit quickly. We'll take a look at a here. We have root 3 plus root 12 is equal to root 27. Really what we want to do is we want to show that this is the left side is equal to the right side. So we can manipulate both of the sides to kind of meet in the middle in this case. Sometimes the teacher will say only manipulate one side to prove it, but I can show you that manipulating both sides and then just rewriting the answer after does the exact same thing. In this case, we can break up our values here. We can break up 27, we can break up 12. 3 is really as low as it's going to go, so we'll leave 3 as it is. Root 12 can actually be broken into 3 and root 4, okay? And if we show this, we know root 4 is 2, so we get root 3 plus 2 root 3. And if we add those together, because technically there's a 1 here, you're going to get 3 root 3, okay? 27, we know that we can break that into 2 factors, and that 2 factors can be root 3 and root 9, and we know root 9 is 3, so we get 3 root 3. Sorry, I had a brain meltdown there. Now sometimes someone may say to you, no, you can't work on both sides, you can only work on one side. If that's the case, what you can do is you can say, well, I know 3 is also the equivalent. 3 is also the equivalent, so what I'm doing is I'm moving up to this step. 3 is also the equivalent of root 9. So I can continue down the ramp here, root 9 and root 3. And if I multiply these together, 9 times 3, well, I get root 27. And that's a little more common in like trig identities. They'll tell you to only work on one side or the other, but you can technically work on both sides. And then, you know, when you got to the equals part, you just bring down the next sentence and then the final sentence, and you kind of just cross this out in the end if you want. And you've all done this all on one side, okay? Let's try another one. We'll try C here. C says 147 minus 75 is equal to root 12. So this one looks a little trickier. We're going to have to definitely break this down. Breaking down 12 will probably be helpful too, but we'll start with the larger numbers we have. So 147, top of my head, I think 3 will go in. Let's see, 3 will go in. Yeah, 3 and 27. Okay, so 3 goes in. So we can say root 3 times 4d9, I think. Okay. What we can do is we can double check that with Desmos. I'll just quickly do the math here. Yeah, that works out. And then root 49 we know is actually a radical value, or equates to a whole number, so we can say 7 root 3. So we've broken that one down. 75, we know we can use 5 here because it's a value of 5, so we say minus root 5, and 5 goes in 15 times. Okay, so 5 in root 15. Now, this one's a little different. It doesn't look like I have a specific value that breaks up easily, but I can break 15 down again. So we're going to continue down the chain here, and we'll say root 5, and 15 is actually broken into root 5 and root 3. Okay, I know I've kind of ran out of space here. I'm going to move to the side a bit. There we go. And what happens here is, well, root 5 times root 5 is actually just the value of 5. So we can say 7 root 3 minus 5 root 3. And now we're stuck on this side. We just get the two, think of them as coefficients, 7 minus 3, and we get 2 root 3, okay? Now I said you could work down the right side, but let's try to reverse engineer this. Well, what is 2 also the equivalent of in radicals? Well, in a radical, I can write 2. 2 is actually equal to, so we can say 2 is actually equal to root 4. So I'm going to replace 2 with root 4, so I have root 4 times root 3. And then I know I can multiply radicals, so 4 times 3 gets root 12. And in this case, I've only worked on the left side to prove that it is equal to what the right side of this equation is.